A stream gradient then is how steep the stream is. Sometimes we call it the profile of the river or the profile of the stream. We're just measuring the difference in elevation between two locations on that river. Those two locations can be rather close together, a couple of feet, or they can be hundreds and hundreds of miles apart. And you average out all of the different stream gradients to get an average stream gradient when you're talking about long distances like that. Bottom line is that the steeper the slope or the steeper the stream gradient, the more erosion is capable of occurring because you're increasing the velocity. So again, think about a really steep slide in a park. All right. When the stream gradient becomes more shallow, the river then has a slower profile to it. And because it's slower, we can't carry as much material. So material is going to get dropped out of that river system. We're going to deposit that stuff. So a stream gradient has to maintain something called dynamic equilibrium. So dynamic means always changing, and equilibrium is a balance. And what is trying to be balanced is the velocity to how much material is being carried. So the stream is constantly adjusting its course, just like we saw with the Oxbow Lakes and with the braided streams. So the river, if it's carrying a lot of water, it has a high volume of discharge, it's got a lot of energy in it, and it's going to have a great capacity to erode the landscape. Well, that is not effective and efficient. Now, note that the river's not a thinking unit, but it's able to adjust itself hydrologically by winding across a flatter area to lengthen out its what we call its run, the distance the river actually travels over space, to slow itself down, creating a more shallow steepness, sort of like when you've got switchbacks on a mountain. It's hard to go straight up the mountain, so we go back and forth laterally across the mountain in order to make hiking that mountain a lot easier. The river's doing the same thing by creating these big meandering beds across a landscape that's shallow because it doesn't want to erode into the landscape very much. However, sometimes the river is not capable of doing this. It becomes trapped within the bed, the channel, and geology of the system. And a really good example of this in North America is something called goosenecks in the Colorado Plateau. When the Southern Rocky Mountains were being created, a large portion of the Southwest popped up called the Colorado Plateau, and it happened so fast in geologic time that the river didn't have time to start to adjust to its shape. So what ended up happening was the stream gradient went from a rather shallow and had all these big bends in it to really steep in this short amount of time. And therefore, the erosion capacity, the ability to do work, increased really quick. So it eroded a really deep canyon as a result. And goosenecks looks like this. So you can see all these ancient bends in the river when the landscape was shallow, but with the uplift changing the hydrology and the capacity to do work, it acted like a little drill, and it drilled down into the geology itself and created this meandering bed. To get a context of how big this river is, if you can see my cursor down here as I'm moving it, that's an automobile. So this is a very, very large system that was created as a result.